Okay, welcome to another episode of Fun with Physics. This is my friend Riker. He's here to help me today with our experiment. We're going to make our own lava lamp. And if I end up using this footage, it's because this footage didn't work. That's why I have two cameras going right now, just so we're clear on that. So today, to make our own lava lamp, what we're going to need some kind of oil. You can use vegetable oil, canola oil, baby oil. Any kind of oil is going to be fine. You're going to need water, some food coloring, it doesn't matter what color you choose, and then some Alka-Seltzer tablets. Of course, it's fine if you want to use generic, it really doesn't make a difference, but we got that name brand because we're bougie over here. And then you're going to need see-through plastic cups or plastic water bottles.
We need food coloring.
And so that's all you need to do the actual experiment. So if y'all want to like pause the video and go get all this stuff and then come back and do it with us, then that's fine. Just wanted to give you guys a quick rundown of basically what we're going to be dealing with today. So when we drop the Alka-Seltzer tablets into the water, the chemical is going to react with the water and it's going to release carbon dioxide gas, which is CO2 gas. And when the gas is released, it's going to start bubbling in the water. But since our oil is less dense but more buoyant than water, what's going to happen is the oil is going to float to the top. The bubbles are going to float through the oil, and the CO2 gas is what's going to fill the bubbles, and then they're going to not dissolve in the oil and the water. It's going to stay separated. So if you've ever seen oil and water together in one cup, you'll notice that the oil floats on top and the water stays on the bottom. That's because oil is less dense but more buoyant. And so the difference here between density and buoyancy, density is the degree of compactness of a material. This is our symbol. It's called Rho, R-O-H. That's what represents density, and then density is just a measure of mass divided by volume. And buoyancy is the tendency of a body to float when submerged in a fluid. And so buoyancy is a force. It's called the buoyant force. And so I have down here that force equals mass times acceleration, because that goes for any force that you're dealing with. But as far as the buoyant force goes, if we want to calculate that, we're going to need to multiply the density times the volume that's displaced. So it's going to be the volume of usually it's the volume of the solid is what we're dealing with, but in this case it's going to be the volume of the oil. And then the G we talked about in our first video, that is the acceleration due to gravity. And so I also wanted to give you guys what units we're in. So for density, we're in kilograms per meters cubed. Mass is always measured in kilograms. Volume is going to be measured in meters cubed. Buoyancy, it's a force, so it's going to be measured in newtons. But I wanted y'all to take note that a newton is just a kilogram meters per second squared, because we haven't talked much about forces yet. So I wanted to cover that. And then acceleration due to gravity, we covered in one of the first videos. It's just going to be meters per second squared. And so now that we know the difference between density and buoyancy, we can go ahead and do the experiment. Riker, you ready?
Xander, come over here.
So I'll let you be on this side. Alright, so we're each going to take a cup. There you go. And now we're going to pour a little bit of water into our cup. You're going to pour the water first?
Too heavy.
Too heavy? Here, you want me to pour it first?
No.
There we go.
You can do the oil.
Do a little bit of water. What color do you want to use for yours?
Blue.
You want to use blue? So I'll take the cap off and then I'll let you squeeze it in there. How about that? Just about 3 drops. There you go. You can do a little more if you want. There you go. Okay. And since Riker's doing blue, I'll go ahead and do green.
Prefer color green?
Green and pink.
Oh, it's like made a circle.
Alright, now you can kind of swirl it up a little bit just to kind of mix the food coloring in. Just like that. There you go. Alright, now you want to...
purple.
It does look purple, doesn't it? Now do you want to pour the oil in?
Yep.
Here, I'll hold your cup for you. How about that? You can go a little bit more.
We're going to have a little
there you
reaction here.
There you go. That's good. Okay, do you want to pour mine too? A little more. Alright. Now if we look, my cameraman Xander has a nice close-up view right now. If you want a view from the top, you might be able to see it a little better. You can see the bubbles that are happening. That's the oil separating from the water. And now if you look
It's
at
like
Rikers,
yellow right here.
if you look at it from the side, that's a really good view because the blue and the yellow.
It's like yellow right here and blue right there.
You see how all the oil is going to float to the top because it's less dense than the water, but it's more buoyant than the water. So if you try and mix it up, it'll look like it's going to mix for a minute. But then if you let it settle, all those bubbles will fill and they'll float back to the top. So we can do a little more oil in mine.
I'm gonna have a little reaction here.
Alright, now you can really see it separating. Alright, so now we're going to take our Alka-Seltzer. And notice that we have our goggles on because safety first, guys. We're not wearing our lab coats because it's way too hot outside. So you want to break the Alka-Seltzer up into little pieces because you're not going to want a whole tablet in here or else you're just going to have way too much going on. So break them into little pieces.
Make sure when you do this at home, be very careful.
Exactly. Listen to Riker. So I'll let you take one. And I'll take one. And so what's going to happen is when we drop these Alka-Seltzers in, they're going to react with the water and they're going to release the CO2 gas and it's going to cause bubbles and we're going to make our very own lava lamp.
Okay.
Are you going to drop another one in there? Can you see them both on there? How fun is that? Ooh, yours looks good, Riker. Here.
Oh, it's turning orange. It's orange.
And drop another one in. Ooh, look at yours.
Man.
Very fun. So that's how you make your very own lava lamp. And if you wanted to, you could even make these in plastic bottles and then put a cap on it and then you can keep it. But we're just making them to show you guys, so we're just going to use plastic cups. But that was it. I mean, it's a very short, sweet experiment today.
Yeah.
Oh, sorry, buddy. We're going to be doing lots more of these. My buddy Riker's going to be helping me out. So if you guys have any ideas or if there's anything that y'all want to learn about or any experiments you guys had in mind, leave them in the comments. And if you guys have any ideas, I'd love to work with them. So thank you guys for watching. You want to tell them bye, Riker?
Bye.
Bye, guys. Thank you.